Hello, everyone. Thank you for joining us in this session of Spokane Public Schools Keep Learning series for mathematics. Today's lesson is for students in grade 2, but everyone's welcome to join in. This lesson is the second in our series. My name is Ellen Nesson, and I'm a first and second grade teacher at Franklin Elementary in Spokane Public Schools. And I'm happy to be your teacher for this lesson, and I'm very glad that you are joining us today. Today we're going to be exploring area using pattern blocks, and I hope you can dust off what you know about repeated addition and multiplication. For today's lesson, and most lessons like this, you will need to grab some paper and pencil if you can find them. I will give you a few minutes to gather your supplies. For today, this is going to be our unit to measure area. It's that green pattern block from the pattern block set at school that you are really familiar with. We are going to get your brains warmed up with some pretty easy questions. If that green triangle is 1 unit, then how many units is the blue rhombus? You've got it. It would take 2 green triangles to cover that blue rhombus. So next question. If the triangle's worth 1 and the rhombus is worth 2, how many green triangles would it take to cover the red trapezoid? You can see that 3 green triangles would fit and completely cover the red trapezoid. So how many triangles would it take to cover the yellow hexagon? You can see that 3 green triangles would fit and completely cover the red trapezoid. So how many triangles would it take to cover the yellow hexagon? You're thinking it takes 6 green triangles to cover the hexagon. Now we're going to combine what you already know about area with what you know about repeated addition and multiplication. So look at this sequence of 5 blue rhombuses in a row. So when thinking about the area of those 5 rhombuses, you might think 2 plus 2 plus 2 plus 2 plus 2. And we know another way of saying that is 5 groups of 2, or 5 times 2. So the question for you is, how many green triangles will it take to cover 5 blue rhombuses? Your turn to think. Good thinking. Those 5 2's all together make 10. It would take 10 green triangles to cover all those rhombuses. Next up, how many triangles will it take to cover this sequence? I see 4 red trapezoids. How many triangles would it take to cover those 4 trapezoids? Were you able to think about some repeated addition like this? 3 plus 3 plus 3 plus 3 equals 12. 4 groups of 3 or 4 times 3 equals 12. Here is a challenge for you. How many green triangles will it take to cover these blue and red figures? And more challenge, can you show your thinking and tell how you figured it out using repeated addition and multiplication? You can share your ideas with an at-home learning partner. Here's another puzzle for you. The question is the same. How many green triangles will it take to cover these shapes? But the numbers you use to show your thinking are going to be a little different. Try to figure out the total number of triangles and explain your thinking with repeated addition and multiplication. Be sure to share your thinking with someone at home. We are going to keep thinking about area with pattern blocks today and about repeated addition and multiplication. Our unit stays the same. We're talking about that green triangle pattern block, and that's going to be 1 unit. Here is the creation that Caleb made. Look at it and think about it for a minute. Try to figure out how many units of area this creation has. We could imagine it covered with green triangles and count all of those triangles by 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for a total of 10. That would work. But we're second graders and we know how to think in groups. So when I look at those 2 trapezoids, I know it takes 3 triangles to completely cover the trapezoids, so I see 2 sets of 3. I look at the blue rhombuses and I know that it takes 2 triangles to cover those, so I see 2 groups of 2. So now it's time to represent our thinking, and that can be the tricky part sometimes. So for repeated addition, I would represent those 2 3's of the trapezoids as 3 plus 3 equals 6. For multiplication, I would say 2 groups of 3 equals 6, or 2 times 3 equals 6. And then the 2 2's, 2 plus 2 equals 4 for the rhombuses, or 2 groups of 2 equals 4, and then a grand total, 6 plus 4 equals 10. So check out this one that Henry made. What groups do you see? This might be how you represent your thinking. We know that there are 3 trapezoids and it takes 3 triangles to cover the trapezoids. So that's 3 plus 3 plus 3 equals 9, or 3 groups of 3 equals 9. Then looking at the rhombuses, I see that there are 2. So 2 plus 2 equals 4, or 2 times 2 equals 4. And then there are 3 singles, the 3 triangles. So it's just 1 plus 1 plus 1 equals 3, or 3 ones equals 3. So the grand total, 9 plus 4 plus 3 equals 16. So here's your job. Look at this design. We want the total surface area of that design in green triangles. That would be a lot of triangles to count by ones. We know that 6 triangles cover a hexagon, so I see some 6's that you can add up and also multiply those groups of 6's. I see some rhombuses, 2 triangles each, so you can add those up with repeated addition and multiplication. And then you've got some singles, some ones to count around the edges. I can't wait to see how you show your thinking. Just a reminder, second graders, I would like to see an equation that shows repeated addition of your 6's and your 2's and your 1's that you count. And I want you to show your groups with multiplication. You can see examples on this slide about how you'd multiply those groups, and then your grand total at the end. Does this look like you're thinking? There are 6 of everything, 6 hexagons, 6 rhombuses, and 6 triangles. So I used those groups to figure out my total. I got 54 total triangles. And here's one more area problem for you to think about today. What is the surface area of this design given in green triangles? So use your repeated addition, your multiplication, think in groups. Try not to just count every single green triangle. Are you ready to get started? I can't wait to see your thinking. I've enjoyed doing some mathematics with you today. Thank you for joining us as we continue to learn from home. If you want more activities, feel free to go to Spokane Public Schools Learning at Home website. I look forward to seeing you again for our next lesson on KSPS.
Hello, everyone. Thank you for joining us in this session of Spokane Public Schools Keep Learning series for mathematics. Today's lesson is for students in grade 2, but all of you are welcome to join in. My name is Trisha Blaylock. I'm a second grade teacher at Grant Elementary in Spokane Public Schools, and I will be your teacher for this session. I'm so glad you're participating with me today. Today we'll be getting our brain ready to practice math by making jumps of 1 or 2 to get to a specific number. For today's lesson, you will need paper and pencil or a dry erase board and marker if you have one. I'll give you a moment to gather your supplies. Let's get started. Meet Leo the rabbit. Like all rabbits, Leo loves jumping. Leo wants to go up these stairs. He can jump either 1 or 2 steps at a time, and he can never jump backwards. So, Leo can jump ahead 1 step like this, or 2 steps like this. Let's help Leo. What if he wanted to jump to the top of this set of 4 steps? What is one way he could do it? Well, the first way I thought of was jumping 1 step at a time until he gets to the top. Like that. Did you think of it that way? So if I look at Leo's jumps, I see that one way he can make it to the top is 1 plus 1 plus 1 plus 1 equals 4. Here's another way he could do it. 1 plus 1 plus 2 equals 4. Here's the last way he could make it to the top of the 4 steps. 2 plus 2 equals 4. Now it's your turn. What if Leo wanted to get to the top of this set of 10 steps? What is one way he could do that by making only jumps of 1 or 2? I will give you a moment to think of one. Did you think of it this way? My first thought was that he could take 10 jumps of 1. As I was thinking about this problem, I had an idea. This reminds me of the work we've been doing using number lines. So instead of thinking about jumps upstairs, I could think about jumps ahead on a number line. Can you find a new way to get from 0 to 10 using only jumps of 1 or 2? I'll give you a moment to work. Here's the second way I found. 2 plus 2 plus 2 plus 2 plus 2 equals 10. So 5 jumps of 2 would get Leo to the top of 10 stairs. Okay, keep working. How many different ways can you find? Share a picture of your finished work with your teacher. I'm sure they would love to see your wonderful math thinking. Thank you for joining us in this session of Spokane Public Schools Keep Learning series for mathematics. If you didn't see our previous lessons, you are welcome to go on the KSPS website. Sometimes it's helpful to go back and watch the other lessons in our series so you can continue to build your understanding of the mathematics we will be doing together.